and putting those on a dashboard for people to interact with. Basically, any way that you would want to communicate some spatial data in an easy to use sort of website format. So, let's see if I can get my slide to advance here. There we go. I also wanted to give you some background on data types and how we structure the data, because that's going to really affect how we can build our dashboards, right? You might have a vision for a certain type of graph or a certain type of symbol you want to place on your maps. And that's really going to depend on how we set up our GIS data. So we refer to that as the data type and the structure of our data in the GIS. So for data types, well, I'm curious, have people heard these terms before? String, integer, and float? Maybe in the classrooms, you can raise your hand if you've heard any of those terms before. Few people, that's great, but definitely not everyone. So there are some special names that we apply to data. If we're thinking about how we store information that we might want to put on a map, we have examples that could be text, right? So for the example of a wind farm or wind turbines, we might have a name that says which turbine is which, or it could be the brand name or some other piece of text that describes that feature on the map. And so we refer to these data types as string. These are text-based data used for names or categories. You might already be thinking, how can we use that data to actually symbolize a map, right? We can use turbine A1 as a label on a map. If we had a specific brand name, you could color them differently if we wanted to figure out, which service technician we need to call for which turbines, that type of thing. And then we've got two categories of numbers, which are really common on maps and dashboards as well. And the first of which is integer. So these are whole numbers, right? If we're describing the number of wind turbines at this project, we could have a count of those and it'd be 15. You can also extend this to population data, right? Integer is really well suited for describing the number of people who live in an area because we can't have half a person, right? We're always going to have a nice whole number when counting that data type. So that's integer data, and it's different from numbers that have decimal places. So if we were thinking about the power output of a wind turbine, that's usually communicated in megawatts, which is just a measure of power. And we could have one turbine putting out 3.45 megawatts. And to communicate that data, we need to store it as a floating point decimal, or we use the term float for short. So if we need precision beyond what we can get from whole numbers, we have to use that float data type. So like I mentioned, we're going to frame this around a wind energy monitoring dashboard. And so I've created what's called a feature service. And it's basically a website that hosts some spatial data. It's going to be just a fake wind farm that I made up for this example, but it could apply to any number of different wind farms across the United States. As you might be aware, there's a really big demand for energy right now, and a lot of different states are kind of scrambling to install enough power generation to support things like data centers, might be people's climate control demands in a increasingly hot summer environment, right? Any number of scenarios demand more power. And so with this rapid build out, people who do GIS are increasingly being called upon to help monitor the progress on those major projects, right? As we're building them out, people who are funding that build out or the companies who are doing it, they want to have a clear communication of what's being done. Are we on schedule? etc. So that's how we're going to kind of frame our dashboard build today. We're building a wind farm. We want to monitor its progress. We want to visualize different attributes of that installation. So in the feature service, which is going to be hosted on ArcGIS Online, and I'll give you some instructions for accessing that so we can all work with the same data. We have information about the wind turbine's status. We have things like the ID number, which we can use for labeling or symbolization. And we're going to have some numerical data describing its voltage, basically how much electricity it's generating over time. So we want to think about how we communicate that precise data with decimal places. And if we're quantifying that data for a particular turbine, right, we're going to, again, need to use those decimal places. So we need to format our data appropriately. So if we only were limited to those whole numbers, right, the integer type data, we could not actually communicate this data appropriately. And there's a lot of other scenarios in which that's also the case. Think about if we were taking soil measurements to monitor the health of the environment with pH, right? pH is often measured more precisely than just whole numbers, between about 0 and 9. We want to have a decimal place to record that type of information as well. Well, let me pause there. Any questions so far? If you got questions, you can put them in the chat, or sure you can raise your hand in the classroom as well, and we can get that communicated. All right, no questions so far. Feel free to post in the chat. Yeah, go ahead, Jeannie.
What if we challenge them to come up with something? What if we ask them if they're doing the microplastics activity and counting the number of microplastics from a water source, what data type would that be? So
yeah, that's a great challenge.
They're collecting water from different sources and they're counting up microplastics. I know that up in Libby, they did that already. I think Bighorn County is doing it today. So this is heads up for what you'll be doing today. And I cannot remember if Hardin High has gone there yet. So perfect. And then we did get a question in the chat. How long have you worked in the field? But let's let them answer which of those three types would counting the number of microplastics in a water sample be?
Yeah, maybe once there's consensus in the classroom, you can put it in the chat, or yeah, if that's the easiest way to do it. So Jeannie, can you tell me a bit more about the activity they're doing later with the microplastics?
Yep. So ideally, they're going to go to multiple sites and look at water either flowing or standing, and they're just going to filter it. I think we gave two filters, one that is more like a coffee filter and one more that's a little bit more like a scientific filter you would use in a chemistry lab. And they're going to look at how many microplastics. I know in Libby, they did find a few microplastics that they saw with a microscope, this little handheld microscope. So we have a couple of years ago, we had students looking at water from the Yellowstone River, and they found long fibers of microplastics. So, I mean, I'm saying long, but long that you would see in a microscope. So
that's a cool activity. And thinking about the data types, it really depends on how you're actually conducting your measurements, right? So if we're thinking about how someone who's making maps might work with someone who's taking field measurements, you've got to be on the same page there. Like if we're collecting a bunch of water and then filtering it to get out of microplastics, and then if you were to weigh it, on a scale, try to figure out what the total weight of the plastic is, that might be a different data type than if you're just counting individual pieces. So
Yeah,
what do we,
that's a good point,
yeah.
actually. Yeah. I just got an email from Yak Valley Forest Council that they cannot, Teams is giving them some challenges and is not letting them type in the chat or unmute. So I don't, that's a bummer because they do typically unmute. But, and I know Katie was able to type into the chat. I'm not sure. Brian, can you try typing into the chat so that we know whether something's going on? Yeah, thanks. Okay, cool. Perfect. Awesome. Great. Brian, what did your students say about the data type for counting microplastics? Sorry, now I'm going to put you on the spot.
They said it's integers.
Yeah, that's a great answer. If you're counting individual pieces, integer would be the best data type. And technically, you could use float, right? You might just not think about it too much and say, I'm just going to start typing this into a spreadsheet program and keep track of the data. And it might be 1.0, 2.0. Not going to cause a huge issue to start with, but imagine if you had a major study, right? If people are doing this all over the country and you've got thousands or even millions of data points, we want to be able to optimize the data that you're collecting, and integer takes up less space. It's faster to work with because you don't have to deal with all the individual decimal points that you might have to deal with float. So understanding the data types can really help you just set up your data set appropriately and unlock different symbolization that is best suited for your data. And then that other example I mentioned, if you were like weighing the mass of the microplastics, you'd probably want to use a floating point decimal because you're going to get some measurement in grams or pounds, right? That's probably not going to be a whole number. So you choose float in that case. One tricky example that I come across quite a bit is zip codes, right? So I live in 59718 in Bozeman. And if you just plug that into a spreadsheet, it is often recognized as a number. But there's a lot of zip codes across the United States that start with a zero. So that can create some issues, right? If you type in a zero before a number, oftentimes your program will just drop that zero. So your zip code becomes incorrect. So you need to pay attention and instead format that as a string, even though all the individual characters there are going to be numbers for a zip code. And then that question, how long have I worked in the field? I started at Montana State. I got hired as a structural geologist in the earth science department in 2017. So I believe I just wrapped up my 8th or 9th year. And I've taught the GIS class every single year, at least once since I've been at MSU. I use GIS in my field data collection as well. So when I'm doing geologic mapping, I'm oftentimes collecting measurements and observations about the rocks in a GIS. I might be using field maps or a different program to collect that data. And I've been doing that for, I started studying geology in about 2006, so coming up on 20 years now. I also do a bit of consulting work that is very similar to what we'll do today with a company called Energy Project Partners, and we help energy projects get built and stay on schedule across the country. Currently helping do GIS for 2 major wind farms in Texas that are being built by AES. So I've been doing that for about 5 years. All right, so thanks for participating in that kind of thought experiment. We want to also relate the data types to the type of symbolization we can use. So let's think about the turbine name, like turbine 01. If we store that in a string value, that's qualitative data. So it's not numerical data. It's kind of like just a description of that feature on the map. We can use that to control the symbols on our map. So if we had a field that said whether the turbine is active or maybe it needs maintenance, we could apply a symbolization based on a qualitative or string value that reflects that status state. And so instead of diving into all the tables of data behind the map, we can just see the symbols showing us that information right on the map itself. For numerical data, both integer and float data types, we can use symbols that change their shape or their color. We can apply a gradient based on the number in the data. So for example, if a turbine has higher energy output, we could apply a larger circle than one with smaller output. And always fun, we could do heat mapping. We could show basically how tightly clustered things are on the map. And maybe we could use a metric like energy production to show hotspots where the most energy is being produced on your map. And numerical data unlocks that possibility. All right, so I mentioned dashboards. I'm not sure how much exposure you've had to these, but I'll just kind of approach this as if people have not really created one of these before, but maybe you've come across them in the news or on a website somewhere. So a dashboard goes beyond just a simple map. And the visuals on the right side, you can see we've got a map sort of at the center. We've got some different symbols on the map, but around that, we've got text, we've got gauges, right? It might be a percent measurement. We could have just a large number telling us something about the data set, like the count of the number of campgrounds on the map, that type of thing. So it goes beyond the map to more clearly communicate the story that's contained in the data. And for something like a wind farm, what we can do is monitor the real-time change in the attributes. If someone updates the map, we can see that reflected on the tables, the graphics that are on that dashboard. And we can create interesting graphics like this serial chart, basically a bar chart. And if we're looking at 4 different turbines here, right, we could use graphs to communicate the differences in their energy production. And to enable this, we need to use a float or integer data type. Right, this particular example uses float because we got the decimal places, and we can precisely see how much power is being generated at each site. All right, so I think we're essentially on schedule here. We're going to get into a more of an interactive portion of this presentation. So we've gone through some fundamentals about GIS and data, how we can store the data and what that allows us to do with the symbols. What I want to do next is create a web map based on that feature service I created. We're going to apply some symbolization, basically explore the different options that are available for different data types. And then we'll get into a build of a example dashboard. The web map we create in the second step here is going to be the key building block for the dashboard. And then we'll have some time at the end where we can have some question and answer. You can share what you came up with on your end, etc. Sound good? All right. So the first thing I want you all to do if you're following along is to get signed into ArcGIS Online. There are going to be a significant number of steps that we have to follow here today. So if you fall behind, I'd say the important thing is understanding sort of the overall concept of what we're doing. And you can try to recreate some of these on your own. But I'll try to go at a pace that allows everyone to stay on track as well. So I'm going to start just by being completely logged out. And I'll go through the process of getting signed into ArcGIS Online. So I go to arcgis.com and hit that big sign in button. You're probably pretty well practiced with this by now. I should also say that if you fall behind or if maybe something wasn't super clear, please feel free to chime in the chat or raise your hand in the classroom. Happy to revisit any steps we go over. So I'm logged into my homepage here at the Spatial Sciences Center at Montana State. Your homepage will look a little bit different. And I've got a feature service that I created. It's called the Montana Wind Turbines Dashboard Demo. And so I would like you all to add this to a map. And so to get started with that, when you're in ArcGIS Online, I want you to select the map link across the top toolbar. So it should look something like this. And we've got a blank layers pane on the left here. Probably familiar, but just in case, right, we've got different navigation tools on the left side here, like you can turn on or off the layers, you can view tables, you can switch the base map, etc. On the right side, we've got contextual tools where if you're working on a particular layer on your map, you can select it and then different tools get unlocked based on what you want to do. So for this exercise, you want to hit the Add button. And it's going to look a little different for me than it will for you. What you want to do is go to ArcGIS Online and search for MT, Montana, Wind Turbine Dashboard Demo. And if you type that in correctly, it looks like the only result that should come up is the one I have created, MT Wind Turbines. I actually made a slight typo there, but still found it. Dashboard Demo, owned by myself, Andrew Laskowski, and you can go ahead and click Add to add that to your map. So I'll pause there. This is an important step, just getting the layer to be on your map. Let me know if you got questions or if you're having any technical difficulties, we can troubleshoot those. If you've already reached this point, what you can do is you can just start exploring the map layer, see how many points there are. You can click on them to get a sense for what are the attribute data that is included with that layer. And we're also going to want to save the map. So I'm going to go ahead and save mine. You can save yours using whatever name you would like. All right, so people in the classrooms, give me a thumbs up if you got this layer on your map already. I got a hand up, got a few thumbs up. That's great, we're making progress. So again, this is not real data, but it looks a lot like what a wind project might look like. The points are not always on a perfect grid, the locations of the turbines. You're often up on a hill because you can access more wind energy from a higher elevation. Uh, You'd want to be near things like transmission lines that can carry the electricity that's generated off to the substation and distributed to houses, whatever it might be powering. Switch the base map if we would like, right? We could turn on the topographic base map, might give us a bit more information about the terrain. Or you could check out the satellite imagery as well. This looks like a cool place geologically. We've got some domes and basins here, but that's a different story. All right, so I want to challenge you to come up with a symbolization scheme for these points that you think makes sense. So to do that, I'm going to click on the layers widget on the left side. I want to make sure my wind turbines dashboard demo layer is selected. And then over on the right side, we've got access to the styles icon. It's the circle, square, and triangle shape, second one from the top. So as I mentioned before, right, we've got the option to show a heat map. Probably not particularly useful in this case because it just looks like hotspots of exactly where the turbines are located. We haven't told it to use any numbers associated with the points yet. We can also just use a single symbol, right? If you just wanted to just make a reference map of where the turbines are located, that might be a good choice. But let's take a couple minutes and I want you to experiment with different symbolization that you can apply. The first step will be to choose a field. So where it says choose attributes, we choose a field. You might choose the turbine ID, the status, the year built, service tickets, etc. So come up with something you like, and in a few minutes, I'll ask someone from the different classrooms to share at least one example of what you came up with. And let me know if you got questions as you're working through this. All right, so if you got access to the chat, maybe just type a quick summary of like what you symbolized. Was it the power output? Was it the manufacturer, the year built? And how'd you do it? With color or graduated symbols? or any other option, heat map, whatever.
This is up in the Yak. We used power output with symbols.
Cool.
Graduated
So
symbols.
did it look similar to mine where the symbols got sized differently with different power outputs?
That is correct.
Great. All right, so we have power output again in the chat. That's a great choice. It definitely is going to be informative to show where on the map the most power is being generated. Jeannie did what I did, which was a bivariate symbolization, right? Where you're actually using two different attributes at once to answer a question. So there's kind of a lot that you can do with these complex symbology strategies. You can say, yeah, so you can map a number like the year, and you can use different colors for the manufacturer to see if like maybe at different times, different equipment was installed. My example here is I chose, I'll walk you through the process if you're curious. I chose two attributes. The first one was manufacturer, and the second one was the power output in megawatts. We can see that the manufacturer has the ABC next to it, which means that it's a string. The power output has the 1, 2, 3, which means it's a number. And in this case, it's a floating point decimal number because it does have, 2.7, 1.8. It's not a nice whole number. And then we can symbolize both of those at the same time. I chose the types and size option, and I set types to the text field, the manufacturer name. So I got different colors representing the manufacturer name. And then I've got the symbol size based on the numerical data for the power output. So with this symbolization, we might be able to ask ourselves, is one turbine manufacturer producing more power than the other? Or is it kind of random across the map area? There's no real spatial trend. Cool. Before we finish with the map, I'm going to do one more thing. I am going to set some labels here so I can see which turbine is which. That's often really useful if people are managing construction or trying to figure out which turbine is which. So if you have the layer selected in the layers pane on the left side, you can choose the labels icon on the right. Looks like a little price tag or something. And that'll bring up the menu to allow us to label features on our map. Labels are turned on right now, but we haven't specified what the labels should be. So they're not actually drawing. The terminology for what that label should actually show is called a label class. So if we want labels to show up, we have to click that button to add label class. And then we can choose, right, which of the fields we want to actually use as the label. Latitude, longitude, probably not super useful, right? The status could be interesting. Is it active or offline? But probably most relevant to the dashboard example is labeling the feature with its turbine ID. So again, I added the label class and just selected turbine ID as the field. Then you do have some more advanced options. If the labels start being unreadable when you zoom out, you can actually change the scale range of where they show up. The default is working pretty well. So I'm just going to leave it, but I just wanted to highlight that we do have options for really customizing when those labels get drawn and how they're drawn. We can also change the style if you want as well, right? You can change the font size, the color. You can turn a halo on or off. The halo is oftentimes a very good practice for labels because it makes the label stand out from the matte background. All right, so I know I asked you earlier to kind of choose your own symbolization style on the map, but for the dashboard build, I think there is one symbolization that is going to be most effective. And so I'm going to return to the styles pane. And instead of choosing a bivariate symbolization, I'm going to choose just one attribute field. So you can remove existing ones by clicking the X, and you can add new ones by clicking that plus fields button. And I'm just going to symbolize based on the status. If we're tracking the construction or the production of this power plant through time, status is going to be a really good field to choose for just monitoring, right? People could update the status to values like, is it active? Does it need maintenance? Or is it offline? And then the colors could tell people who are working in the field which turbines need attention, which ones are functioning well, etc. So I'm applying symbolization based on status, and then we can fine tune that, right? We might want to make our colors a little bit more intuitive. Active, you might choose a green, right? Red, we oftentimes associate with like a problem or stop, right? So I'm going to make active a nice bright green. You can click on the symbol and it should bring up the options for colors. Maintenance, I might choose I'm going to choose like a construction orange color, but you can choose whatever color makes sense to you. And then offline, I think I'll choose like a black color in this case. It's going to be a little hard to read on the landscape, so I'm also going to add an outline color in white that'll make it pop on the satellite background. And if you need to, you can also change the symbol size to make them bigger or smaller. Notice that the outline had a transparency applied, so it wasn't very bright. I'm reducing that transparency so my white outline does show up pretty well. And then it's a little bit thicker than I'd like, so I'm going to bring it back down to 1 pixel. So I know I went through that pretty quick, so I'll pause here and give you a chance to apply your symbolization based on the status. So while you're doing that, I'll just mention that one of the really common workflows for wind energy projects is to have drones do inspections, right? Wind turbines are really hard to look at from the ground. They're also pretty dangerous to climb up on, especially when they're in production. But drones can be used to get really high resolution images of these. And so someone might go into the field and every week or so capture images of these turbines to make sure that they're not starting to fall apart. They unfortunately do have a pretty limited lifespan. The fiberglass that makes these turbines wears out and needs to be replaced. And so the drone inspection is a really important part of that. And we can set up these feature services to allow attachments, right? Things like images. So instead of just having the attribute fields, we could upload images, and people can click on the map features and look at drone images from those turbines that are from, a recent observation. All right, so hopefully you've got your symbolization applied. If it's not exactly like this, it doesn't really matter. We're still going to be able to build the dashboard, but I just wanted to provide you with an example of how I might set this up. And once you're happy with it, you can go ahead and save your map. Any questions or any technical difficulties I can help out with? We're doing good. Cool. Got some thumbs up. So I'm going to move on to the next step. We can hit that or I think it's called a burger menu on the top left, right? The 3 horizontal lines. That lets us access the different areas in ArcGIS Online. I'm just going to go back to my home page. And then from the home page, we've got this icon. It's towards the top right. It's going to be like 6 dots right next to the bell icon. This is where all the different apps live in ArcGIS Online. Lots of different possibilities in ArcGIS Online, but the one we want to use today is called dashboards. And so for me, it's the second row down. It might look a little bit different for you. Once you found that, go ahead and click it to open up the dashboard builder. So again, that's the six button menu, top right, and then find dashboards. And your screen probably looks a lot like mine. Might be blank here unless you've created one of these before. And we're going to want to just click the big blue button that says Create Dashboard. And then it'll ask for a name. Call it whatever you would like. Once you've given it a name and chosen where to store it, I've got a folder going for the Geospatial Skills Camp here, but you don't have to put it in a folder. You can click Create Dashboard. All right. Again, take a pause here just to allow people to catch up and ask questions if needed. While we're doing that, I'll open up the dashboard gallery. This is a cool place. It's linked right here on the homepage. I just opened it in a new tab. That shows some examples of what people use dashboards for. A lot of times local governments will use these or specific research projects. Here's one for the state of California. This one looks pretty cool. The entire state, it's showing the location of power outages updated every 10 minutes. So behind the scenes here, you might have some code that is getting information from the different utilities, updating the feature services on the map. We've got the map that's applying symbols and communicating information with the spatial component. And then you've got a bunch of different gauges and graphics that are showing us the status in almost real time for power generation across the state. So maybe give us a little bit of inspiration with what we can do with these dashboards. So back on my dashboard, first step, as you might have guessed, is to click this big plus button. And we need to connect the dashboard to a map. So we can't do any of these other options here until we've actually supplied a map for the dashboard to work with. So I'm going to select map and then find that dashboard demo map I just created. It's going to present you with some different options. None of these are particularly important for the demo, but I'll just, yeah, I might add a line scale bar to my map. These are the different tools that exist on the map. If you want people using the dashboard to be able to do measurements or search, you can turn those on. I'm going to turn on legend so that people can use it to understand the map symbols. I might also turn on the base map switcher to allow people to change the base map on their own, switch it from a satellite to a navigation map. The zoom in, zoom out buttons can be helpful, although most people know how to just use the mouse scroll wheel to do that. So I've got legend, base map switcher, and zoom in, zoom out selected. All right, and there's my map. Plotting in the center of the dashboard. Just a quick clarification, if you ever need to change the symbols on the map, you have to go back to the map in ArcGIS Online. You can't do it directly on the dashboard. So changing symbols, labels, that all happens in the map. Adding the map to a dashboard and then making some gauges, that's going to happen in our dashboards editor here. And then around the outside, we can see some of the different tools we've turned on, like the base map switcher, the legend. We can see our symbology that we applied earlier is reflected in that legend. All right, now's a great time to save our dashboard. So I'm going to hit the little floppy disk icon on the left side. And just save it with the map embedded. All right, so a little tour of dashboards. I'm going to work our way down the icons on the left side just to show you what options are available to you. We can configure this to work on mobile phones, which is a cool option, right? If you made a map and you want to share it with people who are using like their iPhone or whatever, you can create a layout for that here. We're going to skip over that today. Data sources shows us the map that the dashboard is connected to. Theoretically, you could connect your dashboard to multiple maps at the same time. So if you had two maps, you wanted to compare them side by side, that's possible here. Under theme, you've got options for changing the look of the dashboard. So that's kind of the paint palette icon. I'm going to choose maybe midnight blue for mine, but you can choose whichever one you like. Time zone, right? If you were building this for a specific time zone, like you're working for a company on the East Coast, but you're in Montana, you could actually specify the time zone. You can get tracking information to see who's visiting the site if you would like, but we don't need to turn that on today. Under that top icon that looks like the computer monitor, it says View. This is where we get a list of all the different elements on the dashboard. So we've just got the map right now, but we can go ahead and add another element. And the possibilities are kind of endless here, but let's say we want to figure out how many turbines are made by each manufacturer. Right, with just the map, we'd have to click around and count the number of different symbols on the map or different manufacturers by clicking on the pop-ups. But with a dashboard, we can do that with a serial chart. So I'm going to click Add Element and select the option for Serial Chart. And it's going to ask us what layer on our map do we want to use. And so it says layers from dashboard demo map. We can click on that. And it'll get the layers from that map. And then we can choose a category field. Right, so if we wanted to see the different manufacturers, we can select manufacturer in our category field. And then we can specify what is actually graphed here. And so by default, it chose to count up the number of records that have each manufacturer type, which is exactly what we're going for, right? We want a graph that tells us how many turbines are made by GE Renewable, how many turbines were made by Siemens, and how many by Vestas. We have some options that we can use for fine tuning on the left side. We can go through these. We can change the text color, the font size. We can set it to horizontal or vertical. I kind of like the horizontal look in this case. We can tell it what the minimum value should be. Notice that it jumped to about 10.5 to 13.5. If we wanted to set the minimum value to 0, just maybe more conventional, we can type that in under the value access tools for the option for minimum value. So once you're happy with that graphic, we can hit done, and that gets added to our dashboard. Right, maybe not the best looking dashboard so far, right? We got a giant serial chart over here. We got a map next to it, but we're getting somewhere. I'm just going to hit save to save my current progress. Couple more things we can do to make this look good. From the left side menu, we can click the Add Element button. And it gives us these little plus buttons for the different locations where we might want to add things. And right at the top, I'm going to add like a header. So we can add a title and the information about this, this dashboard. We've got a dynamic title applied right now where it's getting the title of the dashboard automatically. But we could say, we could change that. We could say, call it whatever you like. I'm going to call it the Drew Wind Power.
So you click on the plus where it says header at the top.
Plus, and then if you drag it over to your,
Yeah, if you just click on it,
it'll highlight where you want to draw the element.
yeah.
And headers.
So give it whatever title you would like. You can choose where to put the subtitle, same line or below. You can customize the text colors, right? I set that earlier by choosing a theme. If you're doing this for a company or organization, you could add a logo here. You can add background images, all kinds of different options. So any questions on getting to this point? Anything you want me to revisit the steps for? Let me show you some of the cool things you can do with these dashboards to make them really interactive. As a demonstration, I'm going to click add another element, and then up here in the header, I'm going to click the plus. And going back to our discussion of data types, right? We've got 3 different options here for selectors. The selector is going to allow us to like filter the map to show only certain things on the map. Categories, we'd have to connect this to a string field. Numbers, we'd have to connect it to an integer or a float field. And then dates, we haven't really talked about this today, but if we're storing time information, the date and the time, that requires a different data type. But I'm going to choose category selector. And then this allows us to access things like our map features. So I clicked on the categories from features option. I chose the layer from my web map I added. And then we want to, actually, I want to choose the grouped values option. Bear with me here. The grouped values is still going to target our layer from the map. And then we can choose an attribute field to use for our category selector. So if I wanted to be able to only show specific manufacturers' turbines on the map, I could set up a selector like this, categories from group values, the layer connects to our map, category field is going to be manufacturer, and then we've got a drop down where we can select the different manufacturers. I'm also going to go to the selector options and turn on the option for none. So we want to allow people to select no category to show all the features on the map as well. And then under actions, this is where kind of the magic happens. We can tell this selector to actually filter things in an interactive fashion. So where it says active targets, we need to tell it what things to filter. And we can select both the map and the chart we created.
Hey, can I ask you to slow down and then maybe back up and run us through this one more time?
Yeah, happy to do that.
Thank you.
So starting from scratch, hitting the plus button. And I'm going to go along the header on the top right. There's a plus icon in the header. I'm going to click that. Going to choose the category selector. The first options that come up here are going to be 3 options for the categories from. And let me just say, I've been doing dashboards for quite a while. These menus are really not the most intuitively phrased menus. So yeah, just keep that in mind. But we're going to choose the grouped values option. This screen here pops up. It says layers from the name of our map. We've only got one layer on that map, so that's the one we're going to select just by clicking on it. I'm not applying a filter, so I'm leaving that blank, and then the next important thing to do is select our category field. It just chose a default one, which is the turbine ID, because that's the first attribute. Instead of that, I'm going to click on that drop down and just go down to the manufacturer. All right, the next thing I do after setting up the data options is go to where it says selector on the left side. And the only important option here is the none option. If you scroll down, we want to be able to select none, which will give us all the categories at the same time. While we're here, if you want to, you can customize the text there. Under selector where it says label, you can say select a manufacturer. And then finally, under the actions menu on the left side, for filter, we're going to click on filter. It expands the options, and you've got these little database icons here. Just hit the toggle button for both of those. That's going to tell our selector to filter both the map and the chart we created based on what we select from this dropdown. So I'm going to hit done. Just going to save my work. And so now I can demonstrate how this selector works. If we select GE Renewable, right, our graph on the left side updates. It's only going to show us the number of GE Renewable turbines. The map filters to only show us the points where the manufacturer equals GE Renewable. And you can toggle through the different options here, like the Siemens updates the map, the Vestas updates the map, etc. So it takes a map layer that has a bunch of different manufacturers on there and allows us to select by the manufacturer. We can go back to none to show all of them. All right, so that's kind of the full extent of what I wanted to present and task you with creating on your dashboards. I challenge you to create one more graphic on your own. So you might say add element, and then maybe choose to add another graph like above the serial chart you created. Maybe a gauge type. You can select getting a value from a feature. We could select the power output. And then that'll allow us to scroll through the turbines and visualize like how much power they're producing based on the map attributes. Got some options for how these actually look. The meter could be kind of cool. And you can learn a lot by just clicking around and experimenting with the different options for these gauges. All right, so in the title, in the general options here, I added the turbine ID. And once I apply this, I can actually just scroll through and say, turbine 5 is producing 3.4 megawatts. Turbine 6 is 2, right? You get kind of a cool visualization of that data with that gauge. So again, I want to leave some time for you to experiment on your own, but let me just hop back and wrap up my presentation. And then we'll have some time for Q&A. So again, what we did, we created a web map, we built out a dashboard, we added a couple of gauges and different selectors for interacting with that dashboard. And I'm challenging you to add some additional functionality to that on your own. And so kind of wrapping up, right? Dashboards are a cool tool because they allow us to make our maps interactive, really fine tune what the maps are communicating, and guide the people who are reading your maps to the story you want to tell, right? So data without the formatting and the tools to explore that data is just going to be noise, but a really effective GIS professional knows how to take that data and make it into a coherent story. And so dashboards are just one of our tools for actually doing that. And just wanted to highlight, if you got any questions, you want to reach out afterwards, my email is here. It's just my name, Andrew.Laskowski@montana.edu. You can find my website on Montana State's Earth Science Department website as well. So, any questions? Awesome. Appreciate it, Chris. Thank you. I know I went through a lot, so hopefully you were able to catch at least 50% of what I ran through. And if you did better than that, awesome. But just wanted to show some of the possibilities with these dashboards. Maybe I'll hop back over to my dashboard. Whoop.
I think going back to that microplastics, you all could create a dashboard with the microplastics. Or if you've been using your air quality sensors, an air quality sensor dashboard.
Yeah, and one of the cool things you can do also with the maps, it takes too long to go through this in this session, but you can set up these maps for an app called Field Maps. Not sure if you worked with those on your phone at all, but if you've got an account with ArcGIS, you can use the app called Field Maps to go out and actually update these data in the field. So, all right, if we hop back over to the map, not expecting you to follow along here because I'm going fast, but I'm just opening the map and I want to show you some of the options for setting this up for people to actually update these data. So where it says like configure editing forms, we can set up a form for field workers to go out and update the data. Right? We can say, well, they're not going to be changing the manufacturer field, so I'm going to make that one not editable. The power output, we could connect this to maybe a monitoring system that's on the wind turbine, so it is constantly automatically updated, or you could have people actually reading the data and filling it in. The status, we could make that editable. And then when people go out in the field, like on our dashboard, we can refresh this. There's options to set up your map for editing. If I can find them. Well, anyways, probably a little too in-depth to go through here, but you can set these up so that people can walk around with their phones, click on a feature on the map and update the attribute values, send those directly back to the feature service, and all of your gauges will update automatically, which is pretty cool capability. It's a way of connecting your maps online to what people are doing in the field. So
That's really great.
Yeah.
I think they all use field maps in lab 3.2 where they were adding, we do an asset mapping of food systems. And I think they used field maps to add different food systems. So you could have, 10 people going out to map food systems and they're all using their phone and just adding to it and it updates real time.
Yeah. Yeah, as long as you got a connection, as soon as you commit those edits, they'll be reflected back on the map. So, I mean, City of Bozeman, one example, the police department maintains a GIS dashboard. I've had students who go directly to work in the GIS department for the police because they keep track of all their calls on a GIS dashboard just like this. And as a member of the public, you can say what was happening in my community yesterday. You can filter the map to show the different types of incidents that occurred. And it's updated almost in real time, which is pretty cool.
Yeah, I was really surprised how many like city services are connected to ArcGIS. We live in the western part of Bozeman where there's a lot of new developments and building, and we were able to like jump on and see who's building what and what kind of permits do they have because they're like shutting down streets and how long is the street going to be shut down for, and a lot of that was through ArcGIS.
Yeah. Yeah, it's really everywhere. And GIS can be applied to so many different types of things, right? From police to zoning to natural sciences, studying microplastics, all kinds of different things. Awesome. Well, you have my contact information if you want to shoot me a follow-up at any point. With the remaining time, you can continue experimenting